Hi everyone. Today I want to talk about how I made my very first open source contribution.
Wait a minute.
Honestly, I have already contributed to the CYD firmware where I added new display support, a couple of bug fixes, and some terminal CLI features. So to rephrase myself, today I want to talk about how I made my very first contribution to the Zephyr project. It all began when I decided to change jobs and move to a new city. Why? And which city? Glad you didn't ask. I built my resume using literally every AI tool known to me. I applied on one of the job portals and waited. One day passed, 2 days passed, nothing.
3 days later.
Finally, an HR reaches out from company A. They have opening for city B and city P. But she tells me, sorry, your profile wasn't selected for city P. That location only works on WLAN. Anyways, I agreed to give the interview for city B, and guess what? Rejected.
1 week later.
Different company called, I got the interview, and guess what? I cracked this one. So with an offer in hand, I decided I'm going to learn WLAN and try for CTP with the company A again. Mostly because their HR was still bombarding me with calls every single day. So where to learn than the Linux kernel's GitHub source code, the holy land of all open source drivers. Within an hour of trying to understand the WLAN drivers, I was out, confused, lost. I definitely needed some theory before jumping into the deep end. Then suddenly it struck me, why don't I check the Zephyr project? It's smaller.
That's what she said.
It supports Wi-Fi devices. Maybe it's actually be easier to understand. So I jumped into the Zephyr repo. I got to the Wi-Fi driver and wait. There is an ESP32 folder, and to my surprise I saw a ton of familiar APIs function. I already had experience working with the Espressive IDF, so seeing them here, I actually felt confident. I thought maybe I can crack this. I started reading the code, function by function, from top down, just scheming the architecture. I didn't understand a lot of it, but that was okay. Then I end up in a function called scan done callback function, and I notice a very strange memory allocation strategy being used to handle all the scan access points. Here is exactly what the code was doing. It gets all the number of scan access points, and then it makes a dynamic heap allocation using kmalloc. It multiplies the total number of APs by the size of the record structure, iterates through every single one to extract the data, fires off a callback, and then frees the memory. Do you see the problem here? This is an embedded system running an RTOS. If you are sitting in a dense tech park or an apartment building with hundreds of different Wi-Fi networks bouncing around, this driver is going to try and dynamically allocate a massive chunk of heap memory all at once. Best case, the malloc fails and your scan drops. Worst case, say hello to server heap fragmentation. So I ripped out the kmalloc entirely. Gone. Instead, I created a local structure. I switched out to an API and used ESP Wi-Fi scan get AP record. This beauty doesn't grab everything at once. It fetches the access points one by one. We extract the data, fire the callback, and move to the next. No massive heap allocation required. I also had to add a fallback function. If the fetch fails unexpectedly, we call ESP Wi-Fi clear AP list to flush the rest of the AP directly from ESP32 hardware memory so nothing gets stuck. I ran the test, no crash, pure optimization. Now came the real final boss, getting the open source god to actually accept my code. I analyzed how the top contributor structures their PR. I detailed the exact problem, the architectural changes I made, and the massive stability improvements. I hit submit. The pull request was officially out in the wild. I waited, fingers crossed. Finally, a maintainer reviewed it. They pointed out a few coding style issues, but then he left a comment that absolutely made my day. Nice improvement, thanks. I was hyped. Turns out, I didn't know you could run a local compliance script to catch the styling bugs before pushing. A rookie mistake. Anyways, I made the changes and amended my commit. But after 5 years of working exclusive with Garrett, GitHub PR structures completely tripped me off. I accidentally created a mess with 2 commits. After a quick chat with Gemini, I discovered the magic of git push force with lease, crisis averted. Another maintainer questioned the specific API I used. I clarified the doubts, directly linking to the expressive documentation for the API, and boom, he agreed. All check passed. Reviews done. I had no idea what the next step was.
A few moments later.
I learned that Zephyr puts PR in a mandatory 48 holding queue to catch last minute bugs. The next day I woke up and checked my phone. I had an email from the GitHub bot. Hi, congratulations on getting your first Zephyr pull request merged. We'd love to award you with the Zephyr Technical Contribution Badge. I was hyped. My first ever open source contribution to the Zephyr RTOS was officially in the main branch. And that's folks how I ended up contributing to the Zephyr project. And for the company A, I never applied again. Thank you for watching and see you in the next one.